I hope you guys are doing well. So today we are going to solve the problem of the day for 29th January. Okay, so the problem is, actually I have tried this problem in different ways and I found this solution very good. So today I'm going to explain you the solution. So the problem is redundant connections, right? So the problem states that we are given a graph with we are given an undirected graph using these edges, right? So this is the graph. Now we have to find, right, that which edge is causing us making a cycle, right? So let's see, we have a graph, right? Okay, this graph. Now we are given that 1 and 2 are connected. So this is 1, this is 1, this is 2, this is 3, this is 1, this is 2, and this is 3, right? So first of all, 1 and 2 are connected, so this means 1 and 2 are connected. Then 1 and 3 are connected, so 1 and 3 are connected. Now this doesn't make a cycle. Now 2 and 3 are, when 2 and 3 got connected, right, it makes a cycle. So we will return 2 3. By the time a graph become a cyclic, we will return that edge, right? In this particular example, let's pick this example. Okay, so we are given that 2 1 2 1 5 3 4, right? So first of all, 1 and 2 are connected, so we will make a connection, right? Then 2 and 3 are connected, so we'll make another connection. Then 3 and 4 are connected, so we will again make a connection, right? Then 1 and 4 are connected, right? So this time it becomes a cyclic, so we'll return 1 and 4. So this is what we need to do. We need to create a graph, we need to make a graph, and by the time it becomes cyclic, we need to return that edge. So this is what we need to do. So we can solve this using multiple ways. So we can solve this using DFS, right? We can solve this using BFS, right? For these two approaches for finding the cycle. Okay, so once we will find the cycle, we will say that, okay, this is the cycle, and we can find the least node, or the latest node, or latest edge which is causing the cycle, and we will return that edge, right? So this is for these techniques, we have to make a graph first, and then we have to apply those techniques, right? So this is the one technique we can do. Topic is DFS, BFS. So yes, we can do that. The other technique which we haven't discussed yet is a very unique technique, which is union find technique, right? So this is a very a unique approach and very different approach, in which we will create a graph. We will create a graph in between the process only. And at any time, if we can say that, okay, it is making a cycle, so we will return. So this is this is the better approach, right? Because we don't have to create a whole graph first, and then we don't have to iterate in the graph and find the cycle, and then again iterate through these edges and return, okay, this is the edge, this is the final edge. So no, we don't have to do this. We need. So this is a find. There are two operations, right? First is a find operation, in which for finding the parent node, right? For finding the parent node in O1. Okay, so this can be done in O1. Let's say, so okay, let's say we have a parent node which is 1, right? Because 1 and 2 are getting connected first and 1 and 3 are getting connected first. So 1 is the parent node because it is just a, like it is it came first only, right? Here 1 and 2 are connected node, and then 2 and 3 are connected node. So this is how the graph is made. So 1 is the parent node here, right? So for 3 we don't have to do like, okay, so the 3 is connected with 2, then 2 is connected to the 1, so we don't have to so we will, so for that what we can do, we will map the parent of each node, right? So for this, this operation we are using a map. First of all, we will create each node separately, right? So there is no common edges between any node, and then we will create edges, right? So parent of 2 is 2, parent of 1 is 1, parent of 5 is 5, parent of 3 is 3, parent of 4 is 4. Okay, now what we do then so second operation is union. So for combining two graphs, right? Okay, so okay, let's say we have an edge which is 2 and 3, then we have an edge which is 1 and 4, right? So in a particular example, let's say this is the example, right? 2 1 5 and now 3 4, right? So let's say first edge is 2 comma 3, and the second edge is 4 comma 1 comma 4, right? So this is the 3 graphs which we have currently, right? Now at the time we got a edge which is 2 comma 1, so we have made this edge, so this will become a 1 graph, right? This will become a 1 graph. So we have to combine those graphs. So for that we need a union operation for combining 2 graphs, right? And this will be done in O of n, not O of n but O of 1, O of 1, right? This is all we need to do. So okay, you can say, okay, these 2 operations are done in O of 1, then the whole operation will be done in O of 1 only. No, because for this mapping, right, for this mapping and for making these edges, we need, so creating graph, right? For creating graph we need, so first, so what we need to do, union two different graphs. So okay, we have given that combine node 1 with node 2. So okay, what we need to do is we need to combine both graphs, right? We need to combine both the graphs into one, and the okay, so what will happen is the parent will become 1 only. There not be the 2 parents, there will not be the two parents, right? So okay, so this is the find operation. So if x, so let's say if x, so find x, so find x means find the parent of x. So if x is, so we can say in the parent node, right? So a parent node, the parent of parent node is just a parent node because we are creating this now. So let's say we have created this, so the parent of all these nodes will be 1, right? But how can we say the 1 is the parent node? Because the parent node of 1 is 1 only. Parent node of 4 is 1, parent node of 3 is 1, parent node of 2 is also 1, but parent node of 1 is 1 only. So we can say out of these 4 node, parent node is 1 only. This 5 is also a parent node because it is containing another graph, right? So how can we say if the x is not equals to parent of x, right? So parent of x is equals to find the parent of x, right? So how can we say? So this means, so we can say if, so find x, right? So find the parent of x. So if we want to find the parent of 1, 4, right? If we want to find the parent of 4, what we have to do, we have to find the parent of 1, because in this map we have already done that. The parent in the previous union, what we have done that the parent of 4 is 1, right? And if in any other operation, if the parent of 1 will get different, like, right, in this union operation, right, that will gonna be done, because when we are combining two graphs, the parent will be get deflected, right? So we can say the parent of 4 will become parent of 1. If parent of 1 remains 1 only, then okay, parent of 4 will be 4, and if parent of 1 got changed, the parent of 4 will also got changed, right? So parent of x, which is parent of 4, is parent of 1, because parent of x is 1 previously, and written parent of x. This is done. And in the union operation, right, when we are combining, we can say parent of a, like if we are combining 2 and 1. So parent of, let's say parent of 2 is 3 right now, and parent of 1 is 4 right now, right? So what we are doing, parent of 2, right, which is 3, parent of 3 is equals to parent of 1. Parent of 1 is just 4. So what we are doing is we are making this graph right now. So the parent of 3 will become 4 also. And in other operations, what we will do, parent of 2 will, so as parent of 3 will become 4, when we do find operation on 3, we can say find operation on 2, sorry, we can say, so currently parent of 2 is 3, so this operation will not happen. So this will find the parent of 3, so the parent of 3 is become 4, so ultimately parent of 2 will also become 4, right? So this is how this graph will construct, right? So okay, these two operations is done in O1 and O1, right? Now we are creating the graph. Okay, so what we are doing, if we got an edge, okay, if we got an edge, we just done the union, right? We are just merging the app, but before doing the union, we have to find if both the edges are containing of similar parent, right? So in this operation, right, we have to find, so let's say we are given that 2 or 4 are going to be connected, right? So edges between 2 and 4. So what we need to do, we need to find the parent of 2, which is currently 3. So we will do this operation. So we will find the parent of 3, which is 4, right? Okay, so the parent of 2 will become 4, and then we will find the parent of 4, which is 4 already. So this will get true, because the 4 is equals to 4. So that means we are getting a circle. We are getting a cycle, right? We are getting a cycle, and this also means that this node is creating a cycle. This edge is creating a cycle. So we will return that edge. Otherwise, we will do the union operation. So if we are getting that 1 and 5 is getting connected, so parent of 1 is 4 and parent of 5 is 5. So no, these are not a similar graph, which means this condition will get false, and this will get done. So 1 and 5 will get connected. So parent of 5 is 5 now become parent of 1, which is 4. So parent of 5 will also become 4, or else parent of 1 will become 5 and parent of 4 will become 5. So both the cases are true. this doesn't mean that graph will get deflected, right? This simply means that if all the nodes have similar parent, means all the nodes are belongs to a similar cluster. And if any two nodes in a single cluster get connected, that means they are creating a cycle. So we will gonna return that edge. So that's how we are going to solve this problem. So this is getting solved in 52% time complexity or beat. So I hope you understand my approach of union find. I hope you find this strategy interesting and also knowledgeable for you. Thank you for watching this video. If you have any doubt, you can ask me in the comment section. Also I will share this solution with you. Thank you for your time. Thank you.